Welcome to Advanced Algebra. This is our very first lesson, and the title of this lesson is Expressions and Formulas. Our specific learning target for this lesson, when you are finished viewing this lesson, you should be able to evaluate algebraic expressions and formulas. And most of this should be review for you, so I just want to be very thorough. So first of all, we want to define what is an algebraic expression. And an algebraic expression is an expression that contains one or more variables. Okay, and now variables are things that we don't know what their value is, and so they vary, and so we call them a variable. You need to know the order of operations. Most of you remember this as PEMDAS, which is first of all our grouping symbols. And our grouping symbols, we work from the inside to the outside, so the innermost grouping symbol or the innermost set of parentheses, and then working our way out. After grouping symbols comes exponents, and after exponents are multiplication and division from left to right. These have equal priority. It's just whatever one occurs on the leftmost is done first. And then addition, subtraction's the same thing, equal priority from left to right. Some terms you need to know regarding polynomials. Okay, a monomial is a number or a variable or a product of a number and several variables. The degree of a monomial is the sum of the exponents. A coefficient is a number in front of a variable, and a constant is just a number that doesn't have a variable. So let's take a look at what monomials look like. 3x is a monomial. It's a single term, and it's a product of two monomials multiplied together. 25 is a constant. All constants are monomials. A to the third power is a monomial. It's a single term. X, y cubed, z squared is a monomial because they're all multiplied together. The thing to remember about monomials is there's no addition or subtraction to separate the terms. And negative y is also a monomial. It's like negative 1 times y. Here are some examples of non-monomials. This is not a monomial because it's two monomials that are being subtracted, so it's actually a polynomial. This is not a monomial because it has an exponent in the denominator, so the variable can't be in the denominator. The square root of a, we can only have rational, not irrational numbers, so the square root of a is not a monomial. The cubed root of x, again, we can't have anything with square roots unless they can be simplified. And y to the negative 1 is also not a monomial since it has, it's a square root in the denominator. It's 1 over y. So let me get rid of this here. And this is in my way too. There we go. So here, let's jump into some examples. It says evaluate this expression if we know m is equal to 3 and n is equal to negative 4. So all we're going to do with this one is we're going to plug in wherever we see the letter m, we're going to plug in 3. So right here, we're going to substitute 3 there. And then wherever we see n, we're going to plug in negative 4. And negative 4 is going to go right there. So let's see how we do here. So simplifying that, or substituting, excuse me, we get m equals 3, n equals negative 4. Now our order of operations says we start with the innermost grouping symbol or the innermost parenthesis. And so that would be the negative 4 minus 1. So we know negative 4 minus 1 is negative 5. And we're done with our grouping symbols. Now we got to move outward to exponents. We have a single exponent here, so negative 5 to the second power means negative 5 times negative 5. So we get 3 plus 25, and then now we're addition left to right, which gives us an answer of 28. Here's one for you to try, very similar to the last one. I give you the two values. Go ahead and plug those in and see what you come up with for an answer. And I'm not going to take time to give you the answer in the video. Sometimes I'll give you these problems where it says your turn, and we can talk about those in class. So be sure to ask me what the answers were in class. Here's another example. Again, we're going to be taking x is equal to 8. So wherever we see the letter x, we're going to put a number 8 in there. And wherever we see the letter y, we're going to plug in 1.5. So let's go ahead and do that substitution first. After we plug those in, we want to go from the innermost parenthesis, working our way out. 8 plus 1.5 is 9.5, so we're going to just replace that. And then now we need to do our exponent next, right? So we have to do this 8 to the second power first, which gives us a 64. Multiplication is done before subtraction, so we have to multiply these two numbers. And now we can do our subtraction for a final answer of 49.75. Again, here's one for you to try. Go ahead and plug in those two values for x and y and bring your answer to class. Another example for you. They're getting a little bit more complex, as you can tell, as we move on. So this one, for a, we're going to plug in the value 2. So we're going to have that right here, and that looks like it for a. For the variable b, we're going to plug in a -4 right there. And for the value of c, c is going to be -3. So we're going to have a c there and a c there. So let's go ahead and plug those in. Hopefully I've done that correctly. And now what do we do first on this one? Well, we need to find if there's any parentheses that need to be simplified. I don't see anything inside of parentheses to simplify. So I think I would go to the exponents next. We could work on our exponents, and 2 to the third gives us 8. Okay, we did the multiplication here from left to right. 2 times -4 is -8, and we still have times -3. And we did our exponent down here, and that gave us a 9. And we have 9 minus 5. Now this division bar is also a grouping symbol. So that means we can't do this actual division until we have a single number on the top and a single number on the bottom. So we have to get those all together. So the next thing to do would be to multiply this -8 and -3, which is going to give us a positive 24. And now we could do both the addition and subtraction at the same time. So in the numerator we would have 32, denominator will have 4, and 32 divided by 4 is 8. Again, here's one for you to try. We will look at that together in class just to see how you did. And our final example here, the formula for the area of a trapezoid is given. Area is 1/2 the height times the sum of the bases. H is the height, B1 and B2 are the length of the bases. Find the area. So your height is given right here as 10. It doesn't matter which one you call B1 and B2. I think I called the top one B1 and the bottom one B2, but it's completely random. It doesn't matter. So on this one, what I did was I went ahead and plugged in 10 for the height. Okay, I probably should have done that in red. Oh well. And then B1, I think I called 16. And B2, I think I called 52. So let's see how that comes out. So just substituting the numbers first of all in the place where they belong. And then what we're going to do, our order of operations says we got to do stuff in the parentheses first. So we have 1/2 times 10 times the sum of 16 and 52, which gives us 68. And then we're going to multiply from left to right. So 1/2 of 10 is 5. 5 times 68 is 340. Here's one for you to practice with circles. The area of the circle is pi times the diameter divided by 2. And that quantity is squared. So they want you to write an algebraic expression for the area of the circle. So see what you can come up with on that one, and we'll talk about that in class. That's it for this video. We'll see you next time.